in 2030s. And this specifically requires a lot of research on new semiconductor materials, new circuit structures, how to do circuits that actually can provide the necessary power to be useful in those devices. So this actually becomes a new domain of research, these materials, devices, and the third thing is then that we already talked about this low latency communications. Nowadays we have centralized clouds. Google has them, Amazon has them. Many different players have these centralized clouds. The problem is that the light of speed is glacial. It's really slow. And for instance, from Helsinki to Oulu, it takes approximately 3 milliseconds one way to send information. And if we are targeting, let's say, real-time requirements of 100 microseconds, we need to bring the computing capabilities and the edge intelligence close where the services are needed. So this means that we need to start thinking about this distributed computing and mobile edge intelligence so that we can keep the low latency communication requirements. In some cases, also these privacy issues are very important. And also this AI and machine learning needs to be now distributed. It cannot be anymore in the cloud and you can crunch the data for hours or weeks, but you need to do it now in future systems and very dynamic mobile systems in few milliseconds in order to the data to have any value. And the fourth area is more related to applications and services. What type of things will happen? For instance, this smartphone of today is a rather inefficient device because it takes one of our hands away from us in many cases because we need to have it in our hand. Of course, we have Bluetooth and these kind of things, but we expect to see a lot more new types of data consumption devices. May they be wearables, augmented reality glasses, devices printed on glass, for instance, in cars, you can have it in the windows or somewhere. So this is another area where we are doing research. Holographic displays, for instance, are a very interesting topic for 6G because holographic displays actually start to require these terabit per second kind of data rate. And then there is another issue related to what happens with these ultra high data rate networks. Most of these networks will go indoor. They will be inside the premises. And now this actually starts a new paradigm in operating the network. Since it may be the case that the premises owners actually take a role in operating the networks. And this gives rise to a new concept called micro operators. We may touch that a little bit later in this talk. So, as mentioned already earlier, the flagship has basically 3 goals. One is to finalize the 5G and carrying out technology and system pilot so that the vertical systems actually get the benefits of 5G that we expect to see. And then the most important scientific part is this fundamental technology components development to enable these 6G systems. And then digitalization of society via 5G and 6G. So these are the goals that we have in this program. And so putting it into basically 1 or 2 sentences, what is the vision for 2030 that 6G flagship has devised? And we claim that our society is data-driven, enabled by near-instant, unlimited wireless connectivity. Here again, enabled by. So it means that the data is going to be in the driving seat and this near instant and unlimited wireless connectivity is going to be the enablers. And this actually means that we have these huge data rates, low latencies, but this AI machine learning in the edge of the network, right there where the services are required, is the third dimension, actually utilizing the data available. But this is only one challenge, and there are several other challenges which we have identified with the 6G. First, the vertical driving development was one. Then there is this network architectures changing, new value chains appearing. But then there is this one point which is also still unanswered, connecting the last 4 billion people. So that is also a challenge left for beyond 5G and 6G research. And then this autonomous wireless systems introducing the AI machine learning and this major technology leaps required. So I will touch some of these topics later in this. Here you can see our white paper that was published last September. If you are interested in what kind of key drivers and research challenges there are for 6G in more detail, you can take a look at this white paper, and you can find it from this web address. I will skip this one. You can read them in the white paper. Anyway, the white paper was basically an outcome of a conference that we organized in north of Finland in Levi last year, March 2019, where we had 70 experts from around the world who joined writing this white paper. So it's not an output only from the flagship program itself, but it's an output of 70 experts from around the world. So what are the drivers for 6G research? What are the ones that we are proposing? We are proposing to take a look at the United Nations 17 sustainability goals and somehow map these into a new type of key drivers, key value indicators, so that whatever we do in the ICT system design for 6G, we can in some way improve these areas. The second one is more related to societal challenges. Societies are changing. Education innovations are coming in. Societal services are changing. Health and well-being services. The urbanization versus remote is still existing. Work-life change, automation, personalization are the requirements of the future system. And then we have the same drivers as we had for 5G, the productivity in vertical industries, as well as the technology enablers that are there. But in 6G world, there are some new technology enablers that I will talk a little bit later. And therefore, just another picture of the same thing, drivers of 6G. And we have let's say, a quote or a sentence there that, is it naive to say that we must go from 5G engineering to 6G humanity, or is it imperative? So that is basically just saying that we want to have in the 6G research these softer values, societal challenges and sustainability goals also driving the 6G research. And this actually has been adopted very well in the research community, as well as in the big ICT companies such as Nokia and Ericsson, for instance. In East, for instance, Huawei, ZTE, they are not very keen. They are very technology oriented, but it seems that the rest of the world has adopted our thinking and our view into their own 6G research. All right, then I already mentioned about this, that in the data consumption domain, we start to see that smartphones are likely to be not immediately replaced, but gradually there will be a new pervasive XR experiences coming in through lightweight glasses. And telepresence, it will be made possible by high-resolution imaging and sensing, wearable displays, mobile robots, drones, next-generation wireless networks. And these different kind of autonomous vehicles will come in and having these distributed AI and sensing with integrated head-up displays there. So the data consumption models will change. Of course, we will have for the next 10 years smartphones, maybe even the next 20 years, but this device domain is going to change drastically. And as we now go towards the higher frequencies, it is obvious that we are currently somewhere here in 2020s. We are below 6 gigahertz, so 5G based on 4G evolution. This is somewhere where we are now. And the first revolutionary 5G devices will come out in 2025, which operate at the millimeter wave spectrum bands. And eventually, when we go up to 2030s, we start to see these super efficient short-range radios, which actually will be mostly installed indoors, and they will provide us this 100 gigabit per second to 1 terabit per second radios. So now that we go indoors, the problem is that, for instance, in Finland, we have 3 mobile operators. And it is not, at least to my opinion, feasible that when we go indoors, every operator would bring in their own base station to hospitals and to schools and campuses and industrial plants and everywhere. So we most likely will see new type of players appearing in the market, and we call them either local operators or micro operators or vertical specific service operators, so that these guys know requirements of these different business verticals, maybe industry, health, or energy or whatever. They know the exact requirements from these verticals, and these guys are offering then these premises owners network building and management services, and somehow these then need to be connected to these mobile network operators who still own the most of the customers. So this is a new change in the business models that we most likely are going to have. And this also calls for something else. It calls for regulatory changes. It calls for something that we call sharing-based spectrum chunks, which means that there would be some kind of spectrum that can be shared by different operators with some local licensing algorithms used to share the spectrum. So that in the same locality, there could be several local operators sharing the spectrum on the fly. And there are also other stakeholders that we start to see appearing. We may see data brokers. We may see companies offering digital twins, security as a service type of players, and the whole picture in terms of business ecosystem will become more blurred and more there are more opportunities to be offered in 6G, definitely in the parts where networks go indoors. And yet another thing is about this, we need to really start to think about how do we share data. And the data becomes, people have been saying, the oil of the future. So how do we deal with this data market economy, where the ownership and contractual policies are not yet defined, and how do we define them in the future? So these are becoming more and more important issues for the future. And these need to be solved so that the data-driven society basically becomes a possibility. We have listed in the first white paper some initial key performance indicators. Some of the indicators which are for 5G are valid also for 6G, but of course they need to be critically reviewed, and new KPIs must be seriously considered. And as I mentioned, there are these new softer values like UN SDG-inspired KPIs or transparency KPIs related to these artificial intelligence issues or ethics KPIs. And then you have these typical KPIs that we have in 5G already, these technology and productivity-oriented latency, chip link budgets, energy, and these kind of things. And we have some initial key performance indicators in terms of numbers for 6G available. And for the peak data rates, as you can see, the expected values again go 20 to 100 times higher. So we talk about something between 100 gigabits per second to 1 terabit per second peak data rates in 6G era. The radio latency is defined in 5G to be 1 millisecond, but that is actually not sufficient for many, for instance, industrial applications where you need to have really fast control of systems. Let's take as an example, for instance, collaborative robotics in the future factories where the production lines must be adaptable and robots must be able to do several products in the same line. So need to be able to really define these radio latency parameters. And then the second thing, which is a new one, which is not defined in 5G, is this jitter control. You need to be able not just to control the latency, but when the command comes, it comes exactly at the right time. And that requires very, very, very accurate jitter control. For the machine type communication, specifically for the IoT devices in smart cities and such, the target seems to be somewhere around 20 years battery lifetime. And then about the radio density, there is now this kind of number which is being proposed, 100 devices per cubic meter. Since we now go into more three-dimensional networks, so also the density is now defined in 3 dimensions. Again, the total network traffic increase is expected to be somewhere around 10,000-fold. And then we have the problem of this short range, because when we go higher, the coverage of a base station is basically inversely related to the frequency. And the problem is that now that we go higher, we need to somehow get more link budget to make these 6G base stations operate at any reasonable distance. And this actually can be done using very, very high gain antennas. And when you go to close to terahertz bandwidth, you can actually build in a batch antenna easily antenna arrays that may have tens of thousands of antennas, and that can actually provide you this link budget increase. And this ultra reliability again goes to higher numbers. Here we have max 1 out of million outage, which means 10 to the minus 6. However, in the last year or so, people are talking about already 1 out of 1 billion outage, which means that that basically, so the error rate would be 10 to the minus 9. 10 times more energy efficiency. And then this positioning thing, last year we were talking about 10 centimeters indoors, 1 meter outdoors, but it appears that now people are talking already about sub-centimeter positioning accuracies indoors. Then we were talking about the devices and circuits that need new materials in the future. There has been globally a lot of research in new semiconductor materials, and there are this silicon germanium, which is heavily researched, indium phosphide at terahertz, but the CMOS, which is the currently prevailing technology, is not very well operating in these higher frequencies. So people are looking for even more exotic materials like graphene. So there are a lot of things happening in the materials domain, how to make these new circuits operate. And a lot of things will also change in the air interfaces of the 6G. Now, as I mentioned, the dynamicity of the events happening within the mobile cellular networks is really high. And therefore, machine learning or artificial intelligence will play a major role in link and system level solutions in the 6G wireless network. So based on the conditions of the radio channels, these machine learning algorithms are adapting the algorithms that they are using in transmitting the information. So they are adapting constantly on the fly into the surroundings that is affecting the communications. Another thing that will be very important is these new grant-free access methods. When we, as mentioned, we had one number there was 100 devices per cubic meter. That would mean that one base station in some cases might have a huge number of devices, but they all do not transmit constantly. They might just transmit once in an hour, for instance. And now we need to have new type of access methods into these systems that we are going to build next. And this grant-free or competition-based access is something that is definitely required for these massive machine-type communication devices for allowing such a huge number of devices to exist. It cannot be done in a scheduled fashion that current mobile cellular networks are done, but new thinking is required there. And as we mentioned, we go high into the new frequencies, and currently we are using digital modulation schemes such as phase shift scheme or quadrature amplitude modulation or these kind of digital modulation schemes. But if we want to keep the prices really, really low in the future, there might be, let's say, new thinking coming in that should be a resort to old school, go for the analog modulation schemes in 6G, so that the devices would be easy and cost efficient to make. 6G networking is again something that needs to be changed. As I mentioned, there are a lot of new ideas popping up in this 6G networking and most definitely on the security side as well. And the embedded trust so that we can actually have this idea of ID and locator split is something that we need so that we can actually, for instance, identify malicious devices in the network and shut them out. And then, which is more disruptive. When we go higher in the frequencies, I already mentioned that the fact is that as the wavelength gets really low when we go high in the frequency, and in an antenna array, you can have antenna every lambda per 2, so every half wavelength distance from each other. So if we go for instance, terahertz frequency, so we can have on a 5x5 antenna array, maybe 10,000 antennas. And that actually starts to resemble the CCD cell that we have in digital cameras, right? Of course, 10,000 pixels is not much, but if you go a bit more higher in the frequencies, you can have 1 million antennas, and that starts to be already a 1 megapixel type of a receiving device. And that basically means that that the communication service that we have is definitely there, but it's not only about moving bits anymore. So there will be new types of capabilities coming in, this terahertz imaging, so that you can get an understanding on radio frequencies, what your environment looks like. You can even have, as mentioned, centimeter positioning capabilities, which then offers a capability for godlike mode telepresence. And even at some frequencies, you can sense structures and even some kind of gaseous materials. So these kind of new features, the sensing, imaging, and extremely accurate positioning offers us a new, totally new world of applications that are complementing the communication services that we are expecting to have. So there is just a recap of some of the interesting areas. There are this remote telepresence, holographic projections. This is sort of like just capturing the ideas that 6G is looking at. Not going into any more details, I believe I only have a few minutes left. But if you are interested about the technology enablers in more detail, we are just about to publish 12 thematic white papers, deep dives into different technology areas. And these drafts have already been published in 6gchannel.com. And the final versions of these are coming out on the last week of June, most likely June 24. And here you can see the themes of the white papers. There are some more generic white papers, which are like the 6G drivers and United Nations SDGs, or business of 6G, or validation of trials for verticals. But then you go deeper also in the technologies like edge intelligence, machine learning, RF and spectrum solution, broadband connectivity candidates for 6G, localization and sensing, and critical and massive machine type communication towards 6G. So these 12 white papers are to be published in about 2 weeks' time in the 6gchannel.com. And there you can then, if you are interested in looking a bit deeper into these technology areas, you have an opportunity to go and read these. One more slide. If you are Helsinki based, we are organizing next year the largest mobile cellular related international conference in the world, called the the PIMRC 21 in Helsinki, 13 to 16 September. And I guess that basically concludes what I have prepared in terms of slides. So if there are any questions, I'm happy to try to answer them. I guess there are no questions. For some reason, I cannot see the... cannot see the...
You have a question in the chat. Do you have a chance to take a look at it?
Yes, I'm trying to find the chat because doesn't come out. Here we go. I cannot see the chat box for some reason.
I can also read it to you if you wish.
Oh, please go ahead.
You mentioned about the use of machine learning for adjustments. What sort of adjustments are we looking into here?
In machine learning domain, currently the machine learning is mostly done for huge data sets, so it's about big data. And it's done centrally in centralized data centers. In the future, we talk about small data and we talk about very dynamic data. So we do not have time to crunch the data for hours to get some kind of a data mining solution coming out after a certain amount of crunching the big data. No, the future is about really fast machine learning algorithms where you actually come up with the solution in milliseconds. So that requires totally new type of machine learning algorithms and even distributed machine learning algorithms where several devices are doing together the distributed computing.
Thank you. You have another question. Would you like me to read it to you?
Yeah, please do.
Since some years, blockchain and AI have started as a strong hype. As time goes by, blockchain seems to lose its hype while AI is growing. How would you think that blockchain will make difference in 6G context now than the blockchain is utilized in businesses nowadays?
Blockchain is problematic when it's done in global arena. The problem is that you need to have a huge amount of energy to maintain the distributed ledgers. Whether it can actually offer in a world of 6G localized services, let's for instance take an example of smart electricity grids of tomorrow. There we talk about microgrids, which are basically like a city block area where you might have 1,000 houses and everybody is producing and consuming energy. And you would, in the future, might want to trade energy with your neighbors, but in this localized domain. So it would not explode into these Bitcoin type of huge things, but it would be local and it would be offering the trust and the transparency, and it would not explode in terms of energy consumption. So if these kind of local services would require blockchain, then it might be a good solution for local trading or local control of systems and things. But in global domain, it's of course rather let's say heavy solution.
Thank you, Professor Ari Pouttu from University of Oulu.
So,
before the final pitches, we have the pleasure to welcome the Dean of Aalto University.
Are there anything else, Jari, if somebody else wants to say here? If not, I thank you all. I have consumed my 45 minutes and I let you to go to the next interesting lecture then. Thank you on my behalf and hopefully you enjoyed at least partially the presentation.
Thank you, Professor Ari Pouttu from University of Oulu. Before the final pitches, we have the pleasure to welcome the Dean of Aalto University School of Electrical Engineering, Jyri Hämäläinen.